In this video, we will learn the definition of sequence limit. So if we have a sequence x1, x2, x3, and it goes on xn, and it just goes on the sequence, where xn is a real number and that n is a positive integer, then the limit of xn as n approaches infinity, so the limit of xn, this is going to be equal to L. So what does this actually mean? What does that mean? Well, given any positive integer, sorry, not integer, but given any positive epsilon, there will always exist a sequence subscript n, so capital N, such that for all n lowercase n greater or equal to capitalized N, then the following inequality will hold. And that inequality is absolute value of xn minus L is smaller than epsilon. And here, the L here is the limit of xn as n approaches infinity. Now let's talk about sequence limit with an example. So let's say that this sequence here contains values such that x1 is equal to 1, x2 is equal to 1 over 2, so 1/2, x3 is equal to 1 over 3, and so on, and xn is equal to 1 over xn is equal to 1 over n, and the sequence just goes on. So here, the number is actually equal to the reciprocal of n, right? So 1 over n, that's the reciprocal of n. So we can write the limit of xn as n approaches infinity. So the limit of xn as n approaches infinity. You can write this as the limit of n approaching infinity. This is the limit of 1 over n as n approaches infinity, and this is equal to L. This can be explained by the definition of sequence limit that we saw earlier. So for any given epsilon equals to epsilon 0, we can always find n, capital N, such that the inequality 1 over n minus L, the limit, is smaller than epsilon 0. This inequality will always be, it will always hold. So for any given epsilon 0, and by the way, epsilon 0 is greater than 0, so it's a positive number. It can be a very small positive number, but it's a positive number. Now, is this true? Can we find any value? Can we find any value of n such that this inequality is true? Well, we can actually solve this inequality, so I'm going to erase this. And I'm going to erase this top part here. I'm just going to write xn is equal to 1 over n here. So here, if we solve for this inequality, well then, the limit L, what is L equal to? Well, here, if you take a look at this part, oh, sorry, it's 1 over n here. So if you take a look at this part, well then, what is the limit of 1 over n as n approaches infinity? Well, that's 0. L is equal to 0, right? So L, in this case, will be equal to 0, so therefore, we're solving absolute value of 1 over n is smaller than epsilon 0. So then I'm going to erase this part. So then here, since absolute value will always give you a positive result, well, in this case, it should give you a positive result. You don't need to take a look at those absolute values anymore. So you just take them out, right? And this is smaller than epsilon 0. And if you solve for n, well then n here, well, if you write n on the left side, well then n is greater than 1 over epsilon 0. Okay, so, well then, what is n equal to? Well, n is equal to, the capital N is equal to the ceiling of 1 over epsilon 0. In other words, n is equal to the smallest integer that is greater or equal to 1 over epsilon 0. Let's give an example of epsilon 0 equals to 0.03. Okay, well, so if epsilon 0 is equal to 0.03, then this would mean that n is then equal to the ceiling of 1 over 0.03. And therefore, you would get that n is equal to, I'm going to use blue, so then you get n is equal to 34. So then we say that for the given epsilon equals to 0.03, we find that n is equal to 34. And when small n is greater than 34, this inequality holds. Of course, epsilon 0 here is 0.03, so why don't we just write that in right now? And the limit, and L is 0. Use blue. There we go. Let's explain using a plot. So I'm going to draw a plot here, and 1 over 1, which is x1 is here, and x2 is 1/2, so that's halfway, and it's here, 1/2, and x3 is 1/3, so it's going to be like somewhere here, 1/3. Okay, so assuming that epsilon is equal to 1, well, what is that? Well, epsilon equal to 1 is this, right? Epsilon equals to 1. Then we give that the capital N is equal to 1. So for any value of small n, any small n that is greater than capital N, then the absolute value of 1 over n is going to be smaller than epsilon. And this makes sense, right? Because here, this small n here is the n here, 1, 2, 3, and n, right? And here you can see that as you increase n, 2, 3, you go further down left, right? And this is a smaller value than 1 over 1. So here, 1/4 is like here, and 1/5 is like here, right? So you're getting smaller values as n is becoming bigger, right? So here, anything towards the left from here, it's going to be smaller than 1 over 1. Okay, and we can also assume that epsilon is equal to 1/2. Well then, if epsilon is equal to if epsilon is equal to 1/2, then it would be, we're talking about here, right? Up to 1/2. And then we give that the capital N is equal to 2. And for any small n value that is greater than capital N, well then the 1 over n is going to be smaller than, in this case, 1/2. And here you can see that if you go towards the left, any value here is going to be smaller than 1 over 2. And you can also assume that epsilon is equal to 1/3, epsilon equals to 1/4, and so on. So here you can see that as we get n to be greater and greater, you can see that as n becomes greater and greater, epsilon becomes smaller and smaller. So here, eventually, if n is equal to like 1,000, then you're getting 1,000, 1 over 1,000. Now, it's like here, right? Probably not even that. It's just very small. And here, epsilon would only be this little portion here. That's epsilon. So at that point, you're having epsilon to be like a very small value. However, epsilon cannot be 0. Epsilon is going to be a positive value. No matter how small, it's still going to be a positive value. And also here, you can also see that even though it's very small, there are still values going towards the left, meaning there are still values that are smaller than this very, very small point here, right? So like 1 over 1,000, you can still find a value here towards the left that is going to be smaller than 1 over 1,000.